Okay, so welcome back. Now that you know what an inverse function is, let's talk about how we take derivatives of inverse, what the relationship is. Well, I want to remind you guys that the derivative of a function is equal to the slope of that function, which we think of as rise over run, a change in y over a change in x. That's our rise over run. So if we want to do the inverse slope, well, what do? The inverse slope, so the derivative of the inverse function, we switch x and y. So we just get change in x over change in y, your run over your rise. So the key idea is that this is the reciprocal. So inverse points have reciprocal slopes. And this is perhaps the biggest thing that we can get, the biggest take-home message that I want you to remember about inverse derivatives. Inverse points have reciprocal slopes. So, for example, if 2, 4 is on f of x, meaning that f of 2 is equal to 4. Oh, geez. If f of 2 equals 4. And the slope is f prime of that 2. F prime of 2 equals negative 3 over 7. Then, what that implies is that 4, 2 is on the graph of the inverse function, f inverse of x, and the inverse function of 4 is equal to 2. That means the slope, which we can write like this, it's a little confusing notation, but we write it as the inverse's prime, so the derivative of the inverse, at 4 is equal to negative 7 divided by 3. So it's just a reciprocal slope. The sign stays the same, we just flip the fraction. Now, one thing worth pointing out is that here I put a 4, like here my x value is a 4, even though that's a y value on the original function. My x value in the original function is a 2, even though that's the y value on the inverse function. That's why we plug in the original x on the f and the original y on the f prime. But again, the key idea here is that these slopes are reciprocals. That's the important point. The points, the x and y switch, so the x and y switch, and then we have reciprocal slopes. So I want to show you a couple different examples, but I'm going to talk about how we approach them before we actually do these. Okay, so the way I organize these is like so. So I say this, on my f of x, I just do like a small little chart here. If on my f of x, I have the point x comma y, my slope, my f prime of x is equal to m. If I'm on my inverse function, then I have the point y comma x. My slope is a reciprocal. So my slope, which is the inverse prime of that point y, x, y, and y as being points, the inverse slope of y is 1 over m. It's the reciprocal of m. Once I know these relations, I can fill in the missing parts, right? If I know that x, y is 2, 3, I know the other point's 3, 2. If I know this slope here is 7 over 4, I know the other slope is 4 over 7. Okay, so let's do a couple examples, and we're going to kind of see what type of problems this look like. So for example, if I tell you that f of 1 equals 3, and f prime of 1 equals negative 4, and I tell you that g is the inverse, f inverse function of f, I'm going to ask you to find g prime of 3. Okay. So again, I want to organize this information into a table. So we have f as our function, and then g is like our inverse function here. So on f, we have the point 1, 3. So immediately, I know that I'm going to have the point 3, 1 on g. Now, the other piece of information they give me is the slope here. So I know my slope, my f prime of 1, is equal to negative 4. So the problem tells you to find g prime of 3, which is the derivative at the reciprocal. Okay, well that's the reciprocal at this point. So my slope here, my g prime of 3, would be the opposite, so negative 1 over 4. Okay, so that's my answer. All right, so let me give you a slightly different question here. So now I'm going to give you a point. So I'm going to tell you 2, 5 is on the graph. Of f of x equals x cubed minus 2x plus 1. If I tell you that f of g of x is equal to x, I'm going to ask you to find g prime of 5. Okay, so now this should have your spider senses tingling from the last video. Because if they tell you this is saying that like f and g cancel, that means that f of g are inverses. They have that special inverse relationship. Okay, so what that details is that, okay, let's draw this out. So here's f and here is g. So on f, we have the point 2, 5. So that means on g, we have the point 5, 2. Now my goal here is to find the slope at this point. So g prime of 5, what does that equal? Oh, jeez. Well, oh man, they don't give me the slope for this point at f, but can I find it? What is the slope here? The slope here is f prime of 2. But I think I can find that, right? If I have this equation, I can use that to find it, right? So f prime is 3x squared minus 2. So f prime of 2 is equal to 3 times 2 squared minus 2. That's 12 minus 2, which is 10. Okay, so that means that my inverse slope here is actually equal to 1. Wow, that did not come out right. 1 divided by 10, the reciprocal of this. Okay, now I know it seems weird that we plugged in 2 for my original slope, even though I was trying to find the inverse slope of 5, but remember those switch. Because when 5 is the x on g, that means it's the y on my original function, so I need to plug in the x at that point, which is 2. Okay, let's do one more problem similar to that. So let's suppose, for example, I give you a table again. I'm going to tell you that here we have x, we have f, and we have f prime in a table. Okay, and I'm going to have, say, 0, 1, 2, 2, 7, 10. This will be 3 halves, 4, and 7. And I'm going to tell you this. I'm going to have you find f inverse prime of 2. Okay, so you're going to think that, like, maybe I didn't give you enough information for this, but I actually did. So let's think about it again. Draw out our little diagram. Here's f inverse. On f inverse, we know 2 is an x value, right? So we know it's 2 comma something. Okay, so what does that mean? Well, that means on f, we have something comma 2. So the question we kind of ask ourselves here is, okay, well, maybe I can figure out what this point is. So what x has a value of f of x equal 2? So I'm going to look at my table. Where's f equal to? Oh, it's right here. Again, 2 is an x value on f inverse, which means it's a y value on f. So I look at that point in the table, and I realize that f of 0 is equal to 2, which means this point is 0, 2. On the inverse, it's 2, 0. Okay, now, if I'm trying to find the slope of the inverse function, I can find the slope of my original function, f prime is 0. In the table, that's just 3 halves. Well, if that's 3 halves, what that means is the inverse slope, my inverse derivative at 2, would be flipped at 2/3. So the key on this was recognizing, again, that this 2 is actually a y value in f because it's an x value in the inverse function. But again, we're just taking the reciprocal. So all this comes down to is the x and the y switch, and then these inverse points have reciprocal slopes. Those are the 2 key things you need to keep in mind as you attack these problems. Okay, well, good luck on the homework. Bring some questions to me. Let me know if you need help, and I'll see you guys soon.